Hello and welcome back. In the last video, we had discussed about the different number systems that are available and we use them most commonly. So just take a quick recap before we get started with this interconversion from decimal to binary. So in the last video, we had discussed that there are basically four number systems. First one is essentially decimal number system, and the other three are binary, whose base is 2, octal with base 8, and hexadecimal with base 16. And we have the digits or letters used in those three systems. So now today we will see interconversion from decimal to binary and binary to decimal. So let's get started with decimal to binary conversion. Suppose we have the first number as 156. Now this 156 is a decimal number. As you can see, the base written is 10. So this 156 is a decimal number and we want to convert that into binary. So how shall we do that? So as we know that base of binary number system is 2. So we will divide this decimal number. We will keep on dividing this decimal number until we get the remainder as either 1 or 0. So let's see how we go on. Now we have 156 and we need to divide that by 2. So quotient is 78 and remainder is 0. So we write the quotient over here and the remainder add and we write the remainder adjacent to the number. Now again we divide 78 by 2. So 2 into 39 gives 78 with remainder 0. Now we divide 39. So 2 into 19 gives 39 but there is a remainder 1. Now 2 into 9 gives 19 and remainder 1. 2 into 4 gives a remainder 1. 2 into 2 is 4 with remainder 0. So we write a 0 adjacent to this 4 over here. 2 into 2 gives 4, remainder 0, and 2 into 1 gives 2. So over here we get a remainder 1 right at the end. So it is the same remainder that we are writing. We are writing this particular 1, which is not actually the remainder, it is actually the quotient. Quotient that we obtain upon dividing 2 with 2. So don't get confused. Now whenever we want to convert, now we have this series with a sequence of remainders. So how do we use them to represent a binary number? So it's pretty simple. We just start writing the binary number with the bottommost number at the leftmost side. So as you can see in this picture, there is an arrow that goes from bottom to top direction. Therefore, we write it as 1, 0, 0, 1, 1, 1, 0, 0. As you can see over here, 1, 0, 0, 1, 1, 0, 0. So this is the binary equivalent of 156 that was in decimal number system. Let us see some more examples. Over here we have a simpler number. The number is 29 and we want to divide it by we want to convert it into binary number system. So we start by dividing it with 2. So 29 divided by 2 is 14, remainder 1. 14 divided by 2 is 7, remainder 0. 7 by 2 is 3, remainder 1. 3 by 2 is 1, remainder 1. 1 by 2, obviously 0 and remainder 1. So the number is 11101. So 11101 is the binary equivalent of 29. Next is 41. Actually, it's a decimal number. It is 41.6875. So the number is 41.6875 and we intend to convert this decimal number or a floating point number into binary. So first of all, we convert this 41 into its equivalent binary. The process is same as before, we just divide it by 2. So 2 into 20 gives 41 with remainder 1. 2 into 10 is 20 with remainder 0. 2 5 is 10, 0. 2 2s are 4, remainder 1, 2 1s are 2, remainder 0. So the binary equivalent of 41 is 101001, 101001. Now we have the decimal part, that is 0.6875. So how do we convert this decimal part into binary? To do this, what we do is we multiply this particular decimal part. That means whatever we have after this decimal point, we keep on multiplying that with 2 until we get 0 after the decimal. Just in case you are unable to obtain a complete 0 after the decimal, then you can end this process after multiplying it 5 to 6 times. That will be precise enough. So let us see. 0.6875, we multiply it with 2 to get 1.3750. Now we just take this particular part, that means the part which is after the decimal point, and we multiply it with 2. We get 2 into 0, 0, 2 into 5, 10, obviously. So 0, 1 is carried. 2 into 7, 14, plus 1, 15. We get this 5 over here. 1 is carried. 2 into 3 is 6. 6 plus 1, 7. So we get a 7. So basically the number is 0.750. Upon multiplying 0.3750 by 2, we get 0.750. Now we multiply 0.750 with 2 and we get 1.50. Now again we multiply this 0.50 with 2 and we get 1.0. Now we end the multiplication over here because we have obtained a perfect 0 after the decimal point. But if you get a different example, and in that case, suppose you are unable to get a 0 after the decimal. So you just perform the multiplication at least 5 to 6 times and then you can end. Now, this is one important part. In this case, what we did is we considered the binary number from bottom to top. That is, we used to write 1 0 1 0 0 1. So that is perfectly fine when you want to write a whole number. That means before the decimal, whatever you assume, you will take it from bottom to top. But when you go after the decimal, you have to take it from top to bottom. That means whatever we obtained after multiplying this decimal part, we will consider only the integer, perfect integer part of that particular result. For example, over here we had obtained 1.3750. So we will not consider the entire thing. Instead, we will consider only this particular one and write it here. In the next one, we'll consider this 0 and write it over here. Then we get a 1, so write it here, and this 1. So basically, for the decimal part, in order to convert this decimal part into binary, we need to consider the top to bottom approach. And to consider this whole number part, you need to take the bottom to top. Until now, we saw how to convert a number from decimal number system into binary number system. Now we will see just the opposite thing. That means we will convert a binary number into a decimal number. So let us see how to do that. Suppose we have a binary number 11101, obviously base 2. You want to convert it into its equivalent decimal number. So over here, what we will do is we will take the positional weights. So what we do is we start from the rightmost side, that is the rightmost digit, and a number that one is 0. Next one is 1. This is second. This is third, and this is fourth. So the highest position that we have over here is 4. So we start writing it as 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus, as because we have a 0 over here, so we'll write 0 into 2 to the power 1, and this is 1, and hence 1 into 2 to the power 0. So this 0 1 2 3 4 in the power or the exponent part is nothing but the position of the binary digits over here, or the bits. So 2 to the power 4 is 16. 16 into 1 is 16. 2 to the power 3 is 8. So we write an 8 over here. 2 to the power 2 is 4. 0 into 2 to the power 1 is obviously 0. 1 into 2 to the power 0 is 1 into 1 or 1. Now we sum it up, and after summing we get 29. So 11101 in binary number system is equivalent to 29 in the decimal number system. Let us take one more example. In this example, we have a binary number with a decimal point. So the first part of this number is the conversion of first part of this number into a decimal number system is obviously the same. Let us focus on the second part. In the second part, we have the first digit that we have after the decimal point is numbered as -1, and the next is obviously -2. After that is -3, -4, and so on. So over here we have only two digits after the decimal point, so we write only -1 and -2. Now how do we convert this one into equivalent decimal? It is pretty simple. What you do is you write it as 0 into 2 to the power the position of this one. That means the position of this 0 is -1, so we write 0 into 2 to the power -1. For the next number, that is for the next digit, you have 1. So the position of this 1 is -2, so we write 1 into 2 to the power -2. And obviously the digits before the decimal remain the same. That is 1 into 2 to the power 3, 0 into 2 square, 1 into 2 to the power 1, and 0 into 2 to the power 0. So that part remains the same, and we just add this extra part that is after the decimal. 0 into 2 to the power -1 is 0 obviously, and 1 into 2 to the power -2 is 0.25. So we add up this entire thing to get 10.25 as the result. So the decimal equivalent of 1010.01 is 10.25. That is all for this video, and in the next video we shall see decimal to octal and the vice versa. Thank you.